commenting on things we heard yesterday and try to add some further detail on it. The title I was asked to talk to with climate change and natural resource management in the upper Greater Mekong sub-region, the GMS, and the role of ICRAF scientists. I asked for comments from our various colleagues working here, and I think I'll give more of a general, the philosophy and the ways of working rather than specific results, but hopefully we can get into that in the discussion. So as Prasid mentioned, I work for the World Agroforestry Center, ICRAF. We also have a joint program now within the CGIAR between C4, the Center for Forestry Research, ICRAF, CIRAT, CATIE, Biodiversity, and a number of the international centers working on this whole joint issues of forest, agroforestries and trees have come together now, and I'm within that part leading the specific work on landscapes, so I'm happy to interact with you on any of that. So, just reflecting on what we learned yesterday, I think from almost all the talks we became clear that there is a clear need for, within this issue of climate change, cross-sectoral, cross-disciplinary integration. We heard the new jargon that is going on in Lima this week is now intended nationally determined contribution, the INCs. And I think the rate of developing new acronyms is still keeping up with the rate of increase of CO2 in the atmosphere. We're very good at coming up with new terms all the time. We're not actually very good at managing the increase of global CO2. So now we have to talk about INCs. Before that we had NAMAs, and I think for all practical purposes NAMAs and INCs are the same thing, but they have gotten a new name now. We heard about the Thai NAMA of 6 plus 13.5 is 20%, mostly focused on the energy sector. And we got a bit mixed up between disasters and climate change, whether the way we manage climate change is a disaster, or whether if we want to manage climate change, the disasters are a useful entry point for public awareness. But definitely that interface between climate change and disaster management is an interesting one. And then I think we heard that actually it's not so much about carbon and greenhouse gases as it is about water, droughts and floods, and that's the part of climate change that is most visible and most directly linked to people's lives. That there is interesting progress on real-time monitoring, early warning systems. So I think that's a few of the points we heard yesterday, and to that I think I'll add a few further comments. And I think we did not hear a lot yesterday about land use, land cover, how that shapes vulnerability, but a bit indirect within the greenhouse gas accounting that we had. We heard about the Thai NAMA of 6 plus 14% can be compared with the Indonesian NAMA a few years ago of 26 plus 15, and I'll make some comments about that and make some comparison. Is 26 plus 15 more than 6 plus 13? What do you think? But specifically, and the title of the talk that Prasid asked me is, what is the role of science? What is the role of scientists? What is the role of scientists as the way ICRAF sees it? What is the role of universities and all of us here in the room in that type of public debate that we have? And how can we move this from just talking and inventing new acronyms towards actually doing something? Now, I don't know whether any of you saw earlier this year, there was a eye-catching story that female hurricanes are deadlier than male hurricanes. And somebody had analyzed the data, mostly for the US, and up till 20 years ago, all hurricanes got boys' names, but then in the basis of gender equity, people said, no, they should also be girls' names. So since then, we have alternating hurricanes are named with a boy's name or a girl's name. And somebody analyzed the data, how much damage they do, and they found that hurricanes with a girl's name do more damage and leave more victims than hurricanes with a boy's name. Now, two very famous ones, of course, are Katrina and Sandy. But even if you take these two out as outliers, then you still have the effect that hurricanes that got a girl's name do more damage than hurricanes that have a boy's name. Now, the researchers did an experiment, so they brought students into a room, gave them a piece of paper. That piece of paper was describing the upcoming event. There is a hurricane coming to your area, and isn't that? And at the end of the story was, because of that, you're advised to leave your house and evacuate. And then the question was, in the end, are you going to do that or not? Now, when the name of the hurricane was Alexander, on half the papers, and the other half it was Alexandra. Now, that difference was enough to get 15% difference in response curve. And they did it over 7 of those experiments with different alternations and this and that. So in a behavioral economics experiment, it was very clear that a text that is the same, but except for the name of the hurricane, whether it has a male or female name, leads to a different response in our brains on that front. So we could save a lot of lives in the US if we went back to the old system that all hurricanes have boys' names and forget about gender equity in this part. But the paper there was a lot of response on that. So there was a counter paper that female hurricanes are not deadly. And of course, there is a challenge on the statistics on this. It is, we're dealing in the extreme events range. So what type of statistics should we use? Was there further response yet? Yes, it is appropriate. And after checking all the statistics, we're still back to saying that there is such an effect. And it got to a wider debate about peer review and corruption and any of that. But I think the interesting thing is that in the public response, even if we don't, no one thinks that the hurricane actually know whether they are a boy or a girl. But the way the people respond to that, it makes a difference. Yeah? And in our science, we don't think that the labels matter that much. But if we are interacting with the general public and interacting with things, and we want people to take heed of our stuff, then actually these names do matter, and the way the human psychology is still gender biased does actually influence the way we respond on these things. So, yes, we didn't hear a lot about gender yesterday. I think it needs to come into the debate. A few weeks ago, we saw this picture after the presidents of the US and China, the two countries that together emit 45% of global emissions. They actually agreed that they would somehow do something about emissions. It's not quite clear. I think it is now framed as either a NAMA or an INSEE. And from the question is this glass half empty or half full? It's for the first time that these countries actually agree on anything at all. So from that perspective, the glass is at least not completely empty. And the question is it anywhere near enough? And this week we'll have starting the COP in Lima. Next year, supposedly in Paris, we come to an agreement. But between the types of commitments that China and the US currently make and what is needed to be globally appropriate mitigation actions, there is an enormous gap. Yeah? And we talk about the NAMA is the nationally appropriate mitigation actions. We actually should first of all talk about GAMA. What are globally appropriate mitigation actions? And is the sum of the NAMAs equal to GAMA? And when a country declares its NAMAs, that's nice to do that at a national scale. But is it based on locally appropriate adaptation mitigation action, the LAMAs? So we've been talking since Copenhagen about the NAMA, LAMA, GAMA relationship. Yeah, and we have a number of projects now called LAMA in Indonesia. And what are we learning about LAMAs? Now, going to Lima, you would think that the LAMAs would be important part of the story there. This one stopped working for some reason. Okay, yeah, so here we have this relationship between what is considered nationally appropriate as mitigation action, what would be locally appropriate, and then clearly at the local level adaptation should be the #1 issue in most cases. So what can we do to reduce vulnerability, increase that? But within the international negotiations, are the sum of what all countries commit themselves to, is that enough to keep the overall problem within control. And clearly the message is right now, we're nowhere near any action that is globally appropriate. Yeah, there's a huge gap between what needs to be done and what currently countries are willing to engage with. Yeah, so we have this issue of the NAMA, LAMA, GAMA. And within that LAMA, specifically we've seen the landscape scale as an important scale where adaptation action, vulnerability action can be combined with efforts to reduce emissions and make things better at the overall scale. I don't know, why is it not working? Should I point this way? Okay, yeah. So we think that in Lima we would talk about llamas, but we have lots of llamas in Lima. And then I actually found there is a Llama Lima website, which is interesting, but Lima is this is a Samoan term apparently, and in Bahasa Indonesia as well as in Samoa, Lima means 5. And Malama Lama means understanding. Now, in Indonesia, Lama Lama means that it takes a long time. Yeah, so, and apparently the Lama Lima is an art of self-defense, and I think the bottom line of the story is lots of people will need a lot more self-defense because the global system is not up to it yet. Indonesia was one of the first countries to declare its NAMA, yeah, and actually the concept of NAMA arose in the Bali COP in 2007, together with the issue of RED, the reducing of emissions from deforestation. The nationally appropriate mitigation action was defined there, but it didn't really take off in the international debate until the Copenhagen COP, when countries were asked to declare, okay, if we can't agree on anything, what would you do yourself? Now, in that context, the president of Indonesia of those days, President SBY, made this early call that actually Indonesia by itself would reduce its emissions by 26%, and if there is international cooperation, we can make it 41%. And yeah, that was at a point in time that many in Indonesia thought, well, why would the president do that? He's giving away the table silver. We can now get money for reducing emissions. And why would we declare to do anything ourselves? So we did some analysis of that story from the political economy perspective. But first of all, this is the sort of graph, the way it looks like. So the projected emissions of Indonesia would increase out here. The 26% reduction would bring us here. Plus 15%, we would basically stabilize at the level of 2005. So it sounds very good. We're going to reduce emissions by 41%. But it basically, at this point in time, only means that we stabilize at the level of 2005, which was a pretty high number of 1.6 gigaton per year. But it made a lot of impact, a lot of impression, the way it was framed. Now, why would you do that? What is the motivation? What can Indonesia gain from doing that? Now, when we started analyzing that, we realized that actually, the real thing that triggered Indonesia's response in that was that in the lead up to the Bali COP, in the Nairobi COP, someone had presented the emission data from Indonesia as 2 gigaton of carbon, and no one had any idea what that meant. Until somebody said, hey, now Indonesia is the number 3 emitter of the world. Now that got people started. There was an enormous amount of denial that can't be true. We're not the 3rd biggest emitter of the world. We don't want to be that. This research must be wrong. We have to stop the researchers publishing that type of data. So there was a lot going on at that level in denial phase. But in the end, there was, yeah, when people started looking at the numbers, they actually seemed to be about right. Oops, this is slow. Yeah? And so we now have the initial commitment that Indonesia wants to do something about it itself at the national scale. And at the moment, there's a whole process to work out at the provincial and district level. How can we actually meet that commitment? What does it mean? So all districts or provinces are asked to make their own plan, how they were going to deal with it. What can they do? How can they make scenarios for development that meet that target? Now, when we started to analyze that a bit further, then I remember there's something like Maslow, a psychologist working in the 1940s. He came up with a a pyramid of human motivation. What drives human beings in the way they operate? And of course, they first of all care about security, and they care about having enough to eat and having enough water and being in a secure place, etc., etc. And then they care about social relations, and in the end they care about their core identity. Now, we started framing something similar for a country. What drives the government of a country? And of course, the first thing that any country cares about is its national integrity, and if Indonesia has 17,537 islands, and if someone nibbles off one island, then all the country is upset. We don't want to lose one island. But beyond that, we care about basic, you need to have enough food in the cities, that people are reasonably quiet. We care about economic growth. Maybe we care about the health of our people, but we care about our global trade. And beyond environmental health, actually we have our core identity. And that issue of Indonesia as the number 3 emitter of the world, that touched on the core identity. Indonesia didn't want to be known to be the third biggest polluter of the world. That touched on the core identity that we've seen Indonesia didn't want to be. Ways. So red comes in at a pretty low level in the motivational pyramid. It promises that from now on you can make as much money with not deforesting as you can make with deforesting. Yeah, that the opportunity cost of deforestation could be offset. So it comes in at a pretty low level. You promise a lot of money and you hope that people would then change. And at the same time, the NAMA actually is articulated at that level of core identity. This is what we ourselves think is appropriate. We take charge of things. We're not just following what others do. Now, in between, we have, and that actually is one of the big issues for a country like Indonesia, the issue of the emissions embodied in trade. Yeah, people realize that any ton of palm oil that leaves the country has a certain footprint. Any amount of pulp and paper leaving the country has a footprint. And the emissions embodied in trade globally have been the fastest rising element of our carbon accounting, mostly because of the industrial goods coming out of China. So there is this issue on what are these emissions embodied in trade. Now, if you then look at what the Indonesian NAMA does, but creating a clean image for Indonesia, saying we are going to do something about it ourselves, was actually very helpful in creating a brand for Indonesia that would allow the existing export to continue. So rather than waiting for the red, and so far Indonesia has this one agreement with Norway for $1 billion, but we've only spent a tiny amount of that. The oil palm trade is good for $10 to $20 billion per year. So any small effect on that would be quite important. Yeah, so in our analysis, that self-articulating, actually is a very useful way of creating a branding that allows you to be an economic actor of play. And I think that it would be very interesting from that perspective to look at the Thai, NAMA, and the current debate on INSEAs. To what extent are we actually articulating this is what we want ourselves and this is how we want to interact with the rest of the world, rather than saying we're the poor victims of climate change and we wait for the money from the rest of the world. Within that point of our LAMAs, our locally appropriate adaptation mitigation action, of course, from ICRAF side we are a bit biased, and we do think that trees have an important role to play, both on the adaptation side and on the mitigation side. And I won't bother you with definitions of agroforestry, but there are many, many different ways that trees do play a role in the agriculture landscape, in highly productive modern systems, as you see here, developed in south of France, in coffee systems, in many others. And of course, trees are good for many different types of products. They also help with many different types of environmental services. So against that background, we're interested in what role can agroforestry play within that context of LAMA, the local adaptation and mitigation action. Now, what is agroforestry? Yeah, we can ask the experts and we get many different definitions, and usually they need a lot of words. At the beginning of this year we had the third World Congress of Agroforestry, and in the part of that there was a competition for drawings. So we asked school children in India and neighboring countries to give us a drawing what they think of agroforestry is. And the winner was, you don't believe it, was an 11-year-old girl who came up with this vision. This is agroforestry. And when we asked to explain what it is, then clearly it is about Mother Earth, and we have Earth here, and there are all sorts of things happening on the Earth. And Mother Earth is associated with a tree, and the tree helps to get rainfall and helps food, and lots of goody things are coming from there. People are happy, and it solves problems of biodiversity and erosion and this and that. There's a couple of bad things that it replaces. It replaces all the pollution of the world and this and that. And agroforestry will solve almost all the problems that we've ever had. That's agroforestry, and that's our agenda. And I think in a way, if we see how 40 years ago the term came up, it was in the context of critiques on green revolution, critiques on monocultures, replacing things more complex and more diverse and more functional. And it always has had this element of a new framing, a new way, a green development, a clean development. And within agroforestry, we've had many debates about specific technologies, but in the end, it is about trees and the agricultural landscape. And it is a different way of thinking, a different way of analyzing our landscape, a different way of going about it. And I think our winner of the competition captured that actually very well. Oops. So in more technical terms, we would say there's a whole discourse on mitigation, there's a whole discourse on adaptation, but by and large, agroforestry and tree-based land use with higher soil carbon and more above-ground story is actually at the interface of the two. And being at the interface of the two means that you can't get money from mitigation because you don't meet additionality criteria. You can't get money from adaptation because you're useful anyway. And the things that in a bureaucratic system that actually serve both purposes always suffer from being, okay, the other group can handle that. So we need a system that both adaptation and mitigation are seen as a single joint agenda in order to make progress the way we need to make progress. Now, I still don't know whether I should point this way or that way. Okay. So in a recent paper, we looked at the analysis of mitigation, adaptation, synergy between the two. From the international negotiation stage, they were seen as very different topics. Yet a number of countries have over time realized that we actually need to work together on these things, that we can overlap on that front. So here with the group we analyzed the submissions that many countries make to the UNFCCC and analyzed to what degree are they actually working together, how much synergy is there, and we got this quite interesting results. If we look at the high-income countries on this side, the low-income countries on this side, and the lower middle and the upper middle. So actually the most integrated approaches we see in the lower middle-income countries. Yeah? And they realize that they are vulnerable to adaptation. At the same time, they realize they need to do it. In the high-income countries, we have one section of government dealing with adaptation and a different one dealing with mitigation, and there's not much overlap between the two. So the space for more integrated landscape that does both is actually at the moment the highest in the sorry. Oh, that makes more noise than necessary. And in the lower middle income countries. And we're interested in how can we overcome that hurdle, and to what extent do we need more recognition of the adaptation mitigation interface at the international level to allow countries to make progress on this scale. Now, if you look at the reason why we have adaptation and mitigation as separate topics, then storyline is a bit like this. We have human action that leads to emissions, and emissions change the climate, and the climate impacts on land use and human beings, and that's vulnerability. So mitigation is trying to do something here and try to make sure the climate is not changing as much. Adaptation means we accept that the climate has changed and we need to adapt to it. So they're seen as quite different parts of the story. And in the first 10 years of the UNFCCC, there was still a hope that mitigation could stop climate change and we wouldn't need to adapt. Yeah? And it took quite a long time to realize that We failed with mitigation to the degree that we actually have to adapt, and we are operating in this space now. But there is something in between. And that something in between is what I'd like to talk about with you. Because there is other ways of influencing the climate that are not based on greenhouse gases. And if human action modifies the climate in ways that are not primarily based on the global feedback, where would it sit? Would it be, it would not be mitigation, it would not be adaptation. What is it that can change the climate at the level of people, at the level of our land use, that is not primarily based on carbon or greenhouse gases? Actually, we all know that. We all know that trees are shading, trees are decreasing wind speed, trees are increasing humidity of the air, trees might even influence rainfall. Before we had the discourse on global climate change, there was a lot of work on microclimate, mesoclimate. We knew that trees would modify all that. And it seems when the global climate change discourse came up, we forgot all about that. And if you want to talk about effects of land cover on climate, well, you're not supposed to talk about that. It's all about the macro route. But how much is the influence of trees on temperature? Well, if we measure in crop fields that are surrounded by trees and we measure the maximum temperature at the hottest part of the day, can be 1 degree different, can be 2 degrees different, can be 3 degrees different. How much global warming are we worried about? Well, you heard the 2 degrees as a real threshold on that front. So actually at that micro-meso scale, trees influence climate at the level that we actually worry about. Why are we not talking about it? Why are the crop modelers happy to use the climate data? By the way, what are our climate data? Well, 100 years ago, when people started measuring temperature, wind speed, they realized very early on that trees are disturbing your measurements. And it's better to measure in an open field. So most of our weather stations are in airfields. Yeah, because we actually needed good wind data for when planes started to go. So, but all our climate data are, the default is an open grass field far enough away from trees because trees would disturb your measurements. Well, sorry, trees are not disturbing the measurements. Trees are influencing what you would measure. Yeah, and the effect, but we make all our maps of the climate, and we've seen many models and maps of climate here yesterday, using data that come from these synoptic weather stations. And they have excluded the effect of trees there in the first place. Are we bringing back the effects of tree cover on our climate data? You should ask Atachai in his crop models, but if his crop models respond to 2 degrees warmer things, that if you would have some trees in that field, it would be a different story. And that hasn't happened yet, yeah? And that is part of the thing that so we heard about the urban heat islands. We know in cities that by maintaining or restoring tree cover, we can make the urban heat island into a cool island, and we can change it quite a lot. Well, we actually can do, and we are doing the same in our agricultural landscape. But no one knows yet how much it is. So that's, in that sense, is that adaptation? Is it mitigation? No. It is influencing the climatic conditions of our crops, our livestock, our people, but it is neither of the two. Okay, in doing these things, we realize at this point in time we need a theory of change and we need a theory of place. Yeah, now all of you submitting project proposals these days, they know that we need a theory of change. What used to be the log frame, we now have a theory of change, which allows us to be a little more clear about assumptions and uncertainty. But we still have to propose that by what we do, the whole world will change and everything will happen. We need to make that, to be honest on that, we need a theory of place. We need to say, well, change depends on where you are, depends on context, and we need to articulate where we are, and how that links together. So in our current work, we think it is the interplay of theories of place, theories of change that matter. Well, President asked me to say, what is the role of ICRAF scientists? And in a generic way, we describe ourselves as playing 6 roles. And I think the first 1 and 2 are very common to any academic environment. We are there to help basic understanding, system-level understanding, testing hypotheses, developing theories, developing models about how the world works. Yeah? And within that, there's a lot to do between different disciplines of science, etc., to come to a perspective on how the world works. We do that ourselves, and we actually also play a role in synthesizing research that others are doing. So our roles 1 and 2 are the roles of a typical university scientist, trying to develop the details and trying to synthesize and try to understand a system-level perspective on how the world works. But we have to go beyond that. Yeah? We have to interact on that understanding with the rest of the world. We have to translate that into theories of change. Given what we now understand of how the system works, how could it change? How could it move into a more desirable direction? And at the same time, our theories of change are just theories, yeah? And they need testing. So we engage, and that is our role 4, we engage with landscapes, we engage with real people, systems that are trying out new things, that are experimenting with it ourselves. And if that means that our theories of change are not yet the full story, then it comes back to roles 1 and 2. If the pilots show that actually there is an interesting way here, then we need to move it forward into a more active role of scaling up, scaling out. We need more capacity development, we need to share it more widely. And we have a role in convening policy platforms, convening ways that the policy can take up these more, yeah, so traditional in academia, you are evaluated on your publications and your roles out here. As ICRAF, and as I think many of the people in our room, we're also interested in these roles 3, 4, 5, and 6. Yeah? It doesn't mean that the scientists now tell the world what to do. That has never worked. But we need to actively engage with others to make this change happen. And that's how we see our roles on that. Oops, sir. Now, in doing that, we found, and that started long ago, we heard yesterday a little bit of reference to indigenous knowledge, to local knowledge, but we found in our work that we actually have to be much more proactive in communicating our science with the rest of the world. And it's quite easy to think about the rest of the world as 3 actually very different knowledge systems that interact. And when I say knowledge system, it doesn't only mean the knowledge that people have, the terminology they use to explain it, but it also means the way of learning. Yeah? And we have one knowledge system in the public policy debate, and laws are based on perceptions of reality and perceptions of what is desirable. There's a certain knowledge system in that public discourse, and we can try to understand what it is and what drives people to create new laws and new rules and new regulations. The PEC. We can take the local knowledge systems seriously, from the farmers, from the men, from the women, from the people with different ethnic histories, from the different backgrounds on that. That's the local ecological system and the ways of learning that are associated with that. And as scientists, we have our own way of learning. So we have the LEC-MEC-PEC issue, and we see the real impacts of agroforestry on that interface. Now, as Prasid mentioned, recently I was appointed in Wageningen as a professor of agroforestry, and Wageningen has a theory of education that is based on the so-called T-shaped skills. Yeah? And the theory of education that the university uses is that all people who graduate from the university must be a specialist. There must be at least one topic where they have deep knowledge, and there must be generalists who have broad knowledge on many different topics as well. So the theory of education is T-shaped skills. Now, if you look at the logo, actually, you think you have to be a specialist in at least 2 different topics as well as to meet the logo. But that is the theory of that. Now, I brought into that actually from our perspective on agroforestry, we need to go quite a bit further. And we see the roles of scientists as being, on one hand, able to understand the science and be a specialist or whatever in the science, but we also need to be able to speak at the policy level. And we need to speak the language of policy ecological knowledge. And we need, so instead of the T, we need to move up to the Y-shaped skills. And we see the scientists that we need for agroforestry, for this type of work, to be the interlocutors of 3 different knowledge systems. And I think that might be an idea for Chiang Mai University, the other universities out here to think about as well. How do we go beyond adding technical information to a system to be really aware of the complex interaction between public policy knowledge, local knowledge, and our science. And I think there's a lot of valuable stuff out there. One product of that work is a book that probably some of you in the audience have contributed to as well, that Malcolm Cairns has been working on for the past 10 years. For the last 4 years we heard next year it will be published. Now it actually seems to be published. But that is that a deep understanding of shifting cultivation and the transformations of shifting cultivation and the way we understand that and the way the local knowledge, the public policy knowledge and others interact on that front. That book is part of a series. We've been working on this concept of how trees and people can co-adapt. And co-adapt as an important concept, where the trees have to adapt, the people have to adapt, and the interaction has to adapt. But in the interface of that, we did some work with Bill Clark a couple of years ago about theories of knowledge. And we found actually a very simple classification to be quite useful. So on one hand, we classify knowledge systems, yeah, and the default is things without knowledge. And then we have a perspective on knowledge that there is one truth. And if we synthesize everything that we know, we can come up with the one truth, and that is the one thing that we should work on. Or we have ways that essentially appreciate that we have multiple knowledge systems and that we have to leave it at that point. We can't integrate them into a single truth up front. So that's on the knowledge side. On the action side, well, there's one column, there's one column about no action. Yeah? And the joke is that is you and me every day. No knowledge, no action. But here we have an important category of science for science sake, discovery, learning about interesting things. Even more interesting when we learn about how different knowledge systems interact and how they work, but not immediately linked to action. The second column is based on the concept of a single decision-making entity. Yeah? And yesterday we heard about decision support systems. Decision support systems have been a very popular way of framing it over a long time. And they basically mean that if we bring all the knowledge together to a single decision maker, the decisions will be better. And we can help inform what the best decisions would be if we do it that way. So a lot of technology transfer, even IPCC was initially set up to be at that level. What we found, however, is that the real reality is this messy thing out here. There's no single decision maker. Our landscapes are full of people who make their own decisions, and local government who tries to influence people, and central government tries to influence. So many layers of decision making all try to influence each other, but it's a pretty messy whole. And within that, people use many different types of knowledge to justify what they do, to articulate what they do, and sometimes to inform what they do. So we're actually operating in this very complex thing of what we call the negotiation support systems. Yeah, and if as a scientist we want to be helpful, it doesn't help if we claim that our knowledge is superior to what anyone else has. It doesn't help if we only talk to a central government and say, now you tell them what to do. No, we can be much more helpful by accepting this multiple knowledge, by accepting understanding the multiple actors and engaging with that. And that's sort of the philosophy of how we currently see our work. In that context, we have developed this concept of the knowledge value chain. Yeah? Now, you may know about the value chain in coffee. The price of coffee beans at the farm gate is one thing. The price of a kilo of coffee beans further up on the value chain is maybe 10 times higher. By the time you buy a cup of coffee in a restaurant, you pay 10 times more per gram of caffeine. And when you're willing to go for a Starbucks, you pay 10 times more per gram of caffeine yet again. So the value chain is how much other things we can link up with that caffeine determines the price. Well, we can talk about knowledge. Yeah? So what is the value of data? What is the value of understanding? What is the value of wisdom? Is there a value chain that goes from data towards knowledge, towards wisdom? And we did some work in the context of peatland emissions. A paper published this year is about a mud model and models. Well, started with a write shop where you had a paper about a model of peatland, and the reviewer said it was still a model, and the model was about mud, so we came up with the mud model models, value chain. And within that, we developed this thing that actually, in an issue like peat and peatland emissions, we deal with 4 quite distinct value chains. So on one hand, we need a basic understanding of what happens in peat, and what is the microbiology, and how does it respond to all these things. And on one hand, and on the other hand, we have IPCC default tables that country can use to account for their emissions. And they have been negotiated between the countries, and they are now in a way that if each now in between we have a whole lot of work. What land use systems are there, and what can we typically expect under this and that condition? So there's a lot of work here that goes into this, translating knowledge about what happens in the peat towards final emission factors that can be used in accounting. But yet, that's only one part of the story. Yeah? The 2 other parts of the story are important, are what we call willingness to act. Yeah? When this issue came up of high emissions, Indonesian policy could say, no, there's only foreign scientists who have worked on that. It's not our agenda. There was no willingness to accept these things. There was no willingness to act on it. Only when more Indonesian scientists became involved, and they, within the Ministry of Agriculture, tell you, actually it is true. Well, it might be half true. And now that we have valid Indonesian scientists work on this, it becomes accepted as part of what the government wants to do about. So the willingness to act had to be based on legitimacy of the scientists. But if the government wants to do something about it, can it do something about it? Is there an ability to act? And then we get a whole complex story about permit systems and what's already in the chain of motion, and you can't simply stop it and this and that. So we have 2 other knowledge chains, that is how to go from knowing what the story is towards, is this a policy agenda? Is this something we want to do something about? And is it something we can do something about? But even that, even if those 3 value chains work, we still miss out the most important one, and that is at the local level, the people living in the peatlands, well, they need to make a living, and they will try to make a living whatever way they do. So unless we combine all of this with solutions that work, with land use systems that have low emissions and that meet the local requirements, the other 3 value chains will not lead to results. So an issue like that, and peat, you don't have a lot of peat in Thailand, I know, a little bit, but not much. But we can help it to say what are the value chains, what are the knowledge, what type of things do we need to know, and how do we need to bring it so that it has a chance to influence results. Oops. So on the ground, that means a lot of work interacting with people with maps, interacting with how do they understand the landscape, what do they want, and how can we come about it. at the same time, within that, when we talk about that, of course, as was said yesterday, climate change is not the biggest issue for most people. It is somehow on the horizon. But we need to make sure that our agenda on climate change is part of the much bigger debate on the futures people want, sustainable development. Yeah? And if we take a very quick way of looking at the history of mankind, 10,000 years ago we were here, environmental integrity was high but food production was low. And over time we have moved on this graph like that. We have tremendously increased food production, but by and large at the cost of environmental integrity. If we continue like that, where will we be? Are we ending up in these futures we fear, in the planetary boundaries, and everything goes wrong and we have collapse? Or can we actually change the course of history, bend it from environmental degradation towards increasing productivity, but together with environmental restoration? Yeah? And I think the shape of the curve is quite an interesting one for us. It looks like the forest transition curve. It looks like trees disappearing from the landscape and coming back. But it is, by and large, now what the world is seeing, and that is what we want. We want sustainable development. Yeah? And okay, look at this shape of the curve that we had. Yeah? So we want, okay, this is what we've done, and now we want to move here. That actually looks very much like our forest transition curve. We have lost the forest, have a landscape with few trees, and we want to get back into that. Now, this forest transition curve is the central frame of that program on forest trees and agroforestry. And it is to us both a theory of change. This is what happened over time, as it is a theory of place. This is the way we can understand people still living in the forest and people living here and people living there, as well as a institutional challenge. On the left-hand side, we have institutions of ministries of forestry ruling the place, and they have to give up and give space for other things to happen to make progress. But most interestingly, these things are connected. Yeah? And what happens in the forest depends on what happens in the agriculture, and it depends on what happens in the cities. So we can't have a Ministry of Forestry dealing with the forest and Ministry of Agriculture with the agriculture and the cities dealing with the cities. No, they are closely interacted, and we need to develop our understanding that is doing that together. So this is now the current draft of the Sustainable Development Goals that have been agreed on by our international negotiators, and hopefully next year will be done. Now, there's a lot of fine print here, you can see. But within this, there are all these different things. So sustainable development is about economic growth and decent jobs. It is about gender equality. It is about health. It is about climate change and biodiversity. It is all the agendas that we've had come together. But interesting enough, we don't see them now as separate conventions, as separate things, but we start to see them as, yeah. So unless we can see that as a loop, and unless the consequences of actions are translated to effective ways of influencing the why, we're not going to make much progress. Yeah? So this is our socio-ecological system. This is our agenda to work together. And our ideas about adaptation, mitigation, it's really how can we bring our theories of place together with theories of change and move forward on that. So we've developed this into a generic way of describing the landscapes where we work. Now, in that point, we see landscapes as a system. Yeah? And it's important to realize what it means. It means that an actual landscape is only one configuration, and that landscape could actually be quite differently. So we need to know the envelope. How different could that landscape be? Well, if you're here in Thailand, it won't look like the North Pole in any way. It won't look like, yeah? So there's constraints to how different it could be. But what is that? How different could that landscape be? And what is all driving it? And then, so that means an external question of how does that landscape interact with the debates about climate and water and economic growth and urbanization and all that. And how does it work on the ground? And what does it mean for motivation of people and incentives and knowledge? And what new ways of incentives, knowledge, and opportunities could nudge that landscape into a different direction. Yeah, so taking the landscape seriously as a scale means that we have to ask those questions in that type of way. Now, we recently looked at food security in the paper that Prasit is one of the authors, and we looked at a series of plays. What does food security mean in different parts of the world? Oops. Yeah. And we found there's one configuration where in shifting cultivation is both a forest and agriculture, and as a landscape it provides those functions and you can't really separate. There's a part of the world where we have segregated the forest here and the agriculture there, and we can look at what are the functions of both. There's another part of the world where we say actually there's a gradient and there's agroforestry between the agriculture and the forest, and our jungle rubber systems are an example of that. And there are ways where we see the forest here providing services to the rest of the world out there. Yeah? Well, in our analysis of what does it mean for food security, we found that even in the most remote places, interacting with markets is already an option, and people can outsource their need for staple food even in the heart of Borneo, even in pretty remote places. And the whole idea that food security means growing your own food is not true for the staple food. It may be true for all the fruits and vegetables and other stuff, but not for the staple. Yeah? And in that sense, I think we are learning how to articulate that part. Now, I think I'll have to stop somewhere here, but we are this week launching a new book on climate smart landscapes. It's actually part of a series. So first we had this book on co-adapt, how trees and people co-adapt. Then we brought out a book with the negotiation support toolkit with all the methods of how to map local knowledge, public policy knowledge, scientific knowledge. And now we bring together our experience on climate smart landscapes. Oops. Yeah? And well, this book will be formally launched coming Saturday, and it will be available on the website as of from Saturday onwards. If anyone wants a soft copy now, please tell me, I can send it to you. That brings together a lot of the stories that I've brought here. There is a lot more detailed story about water, about rainbow water. We have blue water, we have green water. Now the way rainfall is generated from atmospheric moisture, we gradually start to understand that tree cover plays a role in that. And we're not just passive, we're not just oceanic water drifting over lands. The recycling plays a role, and I think that's specifically interesting in this part of the world, in the way rainfall in China is partly dependent on recycling of rainfall here. And when you want to talk with your big neighbor in the north, maybe telling them that their rainfall is actually depends on what we do here might be an interesting story to develop. There's a lot of technical work on that rainbow water to develop and articulate further. There's a lot of way we can build on the previous understanding of watersheds like Mekong and others, and the way we can now quantify buffering as a quantitative property, and that feeds into your interest in disaster and disaster management. But I think I better stop here, and I welcome any questions and discussions. And as I said, the book will be available later this week, and it brings together a lot of experience on how we, on one hand, the sentinel landscape, try to understand landscapes as coherent systems, socio-ecological systems. On the other hand, to learning landscapes in how are people themselves learning, how is public policy interacting with that, and how can we move that whole thing together in order to increase mitigation and adaptation as a joint agenda. Thank you.